Welcome to Chem Help ASAP. What are some of the most important functional groups that are observed in IR spectra? Let's see. Let's start with bonds from second row elements to hydrogen. Essentially, all organic molecules have bonds to hydrogen, so these absorbances can provide valuable information for almost any organic structure. Let's begin with CH bonds. These fall into three categories based on the hybridization of the carbon. First, sp3-CH bonds. These absorbances appear near 3,000 wave numbers, just below 3,000 wave numbers. It may be 2950 or so, but below 3,000 wave numbers. Second, sp2-CH bonds. These absorbances appear near 3,000 wave numbers, just above 3,000 wave numbers. So when you see signals in this region of 3,000, you can quickly determine whether you have sp2-CH bonds or sp3-CH bonds. sp-hybridized CH bonds are different and show up around 3,200 to 3,300 wave numbers. None of these CH signals are particularly strong, but the alkyne CH is typically weak. There is one last special CH, the CH of an aldehyde. This bond gives two signals in an IR spectrum, one at about 2,700 and another at close to 2,800. These two signals are very characteristic of an aldehyde. OH and NH bonds are a bit different. NH bonds, like from amines and amides, tend to be weak, but still visible and slightly broad at 3,200 wave numbers or higher. OH bonds, like from alcohols or carboxylic acids, are stronger and broader, especially the acid OH, at 3,200 on down to 3,600 wave numbers. How about CO, CN, and CC bonds? The signals from CN and CC bonds are actually not very useful for interpretation. They tend to be in areas of other signals and rather weak. CO bonds, on the other hand, are often strong enough to appear clearly at around 1,200 wave numbers down to about 1,000. CO bonds are seen in alcohols, ethers, often two signals, and esters, often two signals. How about double bonded functional groups? Let's consider the CC and CN double bonds. We'll save the CO double bonds, carbonyls, which are special, and give them their own video. So alkenes. Simple alkenes appear very close to 1640 wave numbers. There is another place you often find CC double bonds. That's in benzene rings. These CC bonds also show up in an IR spectrum, normally very close to 1,600 wave numbers. Why don't they appear at 1,640? Well, remember that benzene rings have resonance. The electron density in the pi bond between two carbons is actually delocalized. The bond is actually some blend of a double bond and single bond. The bond is weaker than a double bond. Stretching the bond requires less energy, so the absorbance appears at a lower value, 1,600 instead of 1,640. CN double bonds appear around 1,650 to 1,700 wave numbers. This is a useful signal, but CN double bonds, amines, are not a very common functional group. There are two triple bond functional groups, alkynes and nitriles. Both of these absorbances appear in similar but distinct places. The alkyne stretch appears just below 2,200 wave numbers. Nitriles appear just beyond 2,200 wave numbers. These are weak signals, but they appear where almost no other signals appear, so they stand out and are very informative. One comment about alkynes: normally only terminal alkynes show an absorbance. Internal alkynes without a CH are often too weak to see, so you can confirm an alkyne by seeing not only a peak below 2,200 wave numbers, but also the weak SpCH signal at 3200 wave numbers or so. That was a quick summary of many of the key absorbances in the IR spectra of organic molecules. Carbonyls are in the next video. Please like, subscribe, or leave a comment. Take care.